Okay. The first question is asking to draw a slope field at 2 different points. This is a 2-point question. Basically, when you draw a slope field, a solution is you're going to start at the point they give you. They give you 3, 2, which is right here. And then these little tangent line segments show you which direction to move. So it tells me it has a positive slope, and then it starts flattening out. Just follow the curve. It's 1 point for that graph. The next one is 0, 8, which is right here. Notice it has a negative slope, so I'm going to start heading down, but then the lines start getting flatter, and I see a horizontal asymptote. So it's 2 points for part A. Okay, Euler's method. Make sure that you label your points. So the point here is t, y instead of xy. The slope is given. Your dy or delta y will be slope times delta x. So I start at the point 0, 8. I plug this into my slope formula, and if you do this, you should end up with your first slope is -2. So how do I find the change in y? I'm going to take my slope. Delta x is going to be 1/2, because we're starting at 0. We're trying to get to 1. You want 2 steps, equal sizes. So your dy is -1. So your x, you're going to move up by 1/2. Your y, you're going to move up by whatever this value is adding on to the previous. So 8 plus -1 gets you to 7. There's my new t, there's my new y, plug it into the formula, and this is going to give you a slope of -7/8. So -7/8 times 1/2 is -7/16. So the next point is 1 comma, add this over here, and you get 6, 9 16ths, or you can get 105/16ths, but this is my point I'm looking for. Please either underline or circle this value so they know that's your final answer. It is 2 points always for Euler's. You got to have all the work going with it. Okay, part C, write the second degree Taylor polynomial. Okay, let's think about how we write a second degree Taylor for about t equals 0. So the first point should be f of 0, then f, and this is going to be for f p of t. There's no x. F prime of 0 times t plus the second derivative 0 times t squared over 2 factorial. Okay, let's figure out what pieces that we have. Okay, first of all, f of 0 is given as 8. I got to figure out f prime of 0 and the second derivative. Okay, your first derivative, they give you the formula, dy dt, okay, and I want to know what happens at t equals 0. So I'm going to plug in the value here. And I know at t equals 0, the corresponding is 8. So I'm going to plug in 8 for y. So 6 minus 8 is -2. And if you notice, we already figured that out from Euler's method here as well. So there's my first derivative that I'm going to use. My second derivative, I will need to calculate the second derivative here. My second derivative, I'm going to go ahead and use the first derivative and take the derivative of this. Okay? So my second derivative is going to be 6/8 times dy dt minus 2/8 y times dy dt. And before I actually calculated the second derivative, I went through and multiplied it out. So I would do this first and then take the derivative from there. And this value is -2 here. And then you can plug in t equals 0, and the corresponding y with t equals 0 is also y equals 8. So you have every single one of these values, and if you plug it in correctly, your second derivative value is 5/2. So let's plug it in to my second degree polynomial. F of 0 is 8. My first derivative is -2 times t. My second derivative is 5/2 times t squared over 2 factorial. This is my second degree polynomial, and then they want you to use this to approximate f of 1. So if I plug in 1 for t, this becomes 29/4. Oops. Okay, and this is a 4-point question. Okay, last question, what is the range of f? So what is the y values for f when t is greater or equal to 0? Notice when t was exactly equal to 0, it's 8. So we're just really looking at this portion of the graph. So notice the y value. It doesn't get anything less than 6, and then it goes all the way up to 8 at 0, which is where we're going to stop. So the range is just going from 6, not including it, all the way up to 8, but including it because that is a point in the graph. It is 1 point here.